And there we are. OK. I guess everybody can hear right. Yeah, sounds like it. Well, welcome everybody. We're in the Web Engines Hackfest. I think I have put the right venue there. And well, there was a really nice introduction by my colleague, so I'm not going to stop in here much. But I think I still look pretty much like in the picture. Different hat, though. I like hats, too. I think everybody knows about Igalia. We do a lot of stuff on web engines, but also on other stuff, like compilers, Node.js, GStreamer, Mesa, graphics. Everybody knows. I don't want to stop here a lot. But let's go to the meat. And this is what I'm going to talk about today. Last time there was a talk in a Web Engines Hackfest about WPE-Android was over 2 years ago. And along the years, we have had a couple of kind of birds of a feather sessions, mostly for the people interested in the project to discuss how it was going to evolve and so on. But we have not been presenting about it to the wider public, how it has been doing. And that's what I'm going to do today. I'm going to go quickly through an introduction about WPE, and in particular, how WPE relates to making WebKit work on Android. We'll comment a bit on the project history, because when I went to check, it has actually been a few years that it has been going on. And then I will get also into what's the motivations when I get there for having WPE WebKit running on Android, and also what's the current status and what we think is the next things happening around the project. So beginning with WPE, well, in particular WebKit, because it's not a WebKit port. Is WP is the port. WPE-Android is the WPE port made to work on Android, so it's a bit kind of long-winded explanation. But it's going to be clear. Everybody knows here, because we're in the Web Engines Hackfest, this is a web engine, picks all your content, makes it look pretty, makes the cats appear, and YouTube videos have sound, and you can watch mother talking and listen to them and all that kind of thing. One of the things of WebKit, which is crucial for the work that it enables with for this particular project, is that it's portable, in the sense that, not portable that it can run in different platforms, that's of course yes, but portable in the sense of what we call a WebKit port is an adaptation of WebKit for a particular platform. Which means it runs in more things that one can imagine. Along the years we have known about WebKit running in many places. And the thing is that because it can be made to run in many things, sometimes there's devices that have web interfaces that are running WebKit that we don't know it, because the web interfaces are designed to blend with the rest of the interface, or the whole interface is a web interface, but it doesn't look like one, because it's customizable enough that you can make it look that way. So I'm sure there's still places where it runs that we don't know yet. And in particular, WPE, the WPE WebKit port focuses on embedded Linux systems, embedded both in the sense of small systems and embedded in the sense of the web engine is embedded in a bigger system, and one might not necessarily know that it's there, in the sense that blends with the rest of the platform. Like I was saying, is what enables it to be in many places without maybe noticing. And yeah, that's what I was saying. And the thing is, it's very extensible. We can make many things on top of it. It has a public API that is designed for embedding. Gecko, for example, had at some point a Schulrunner, which allowed to use the Mozilla engine in other applications. It was abandoned at some point. Chromium is not particularly designed to do that. It can be done in different ways. For example, removing the browser Chrome and using the content shell layer, etc. So there's like side projects which add such an API to be able to make the web engine part of different applications or part of bigger systems. But that is intrinsical to WebKit. It's every WebKit port has a public API that is ideally, in our case, is stable and is guaranteed to remain stable for as long as possible. And that means the API the embedding API has to provide anything that a browser may need, and also other applications that may need to use it. But if one can make a browser with a public API, one can imagine that pretty much one can write almost anything. And having written that it has minimal dependencies, and the minimal has a footnote. It does have a number of dependencies, but it's remarkably easier to make it work on a new system because many things can be made optional at build time. And the dependencies we have currently are not bleeding edge. So they are packaged in most systems or available in embedded systems already. Not on all of them, and I will mention about this later because it's a bit of a pickle in Android. But it means that itself, WPE WebKit is not very big. Like, we don't bundle everything we need, but the things you need to have to build it and run it is not that much. The most complicated part is GStreamer, and if you are like port into a new platform, you can even disable the whole multimedia stack to have something running at first, and then you avoid most of the dependencies, for example. And when we talk about WPE and this customizable, means that on Android, because WPE doesn't, we need to provide platform adaptation and also a custom widget for the Android native user interface system. And that is, this is provided by 3 different components, and I was saying dependencies, yes, Android doesn't have many of the dependencies we need to run WebKit, but the GStreamer team has this project called Cerbero, or Cerbero, which uses the Android native development kit to build all the libraries that GStreamer needs. So we figure out if we have GStreamer built for Android, thanks to this. If we have the 3 or 4 extra additional things we need for WebKit, then we have everything already. So we reuse this project, and using the official Android native development kit, we are able to build all the dependencies for WPE WebKit and WebKit itself, the WPE port. And also the WPE backend Android, which is the part that provides platform integration. And then we have what we call the WPE Android proper project, which is what has the glue code that provides the widget that exposes a Java API, which is the usual thing on Android, and can be used from any other language that runs in the Android runtime Java virtual machine, and has some tools like a WebDriver host and all the needed glue code to make everything work. So WPE Android is, in reality, these 3 projects put together. And if one builds it, one ends up with a mini browser, which is a sample application, which looks like this. Is quite simple. Could have a few more features, but it's enough to browse around, see that things work, and yeah, it's an Android application. Doesn't look particularly special from that point of view, unless one knows, well, this is not running Chromium, which is the usual thing on Android. First aside about the history of the project, I want to recap that WebKit has a long history with Android, because when Google released Android in 2008, it was using WebKit as the system web view component since the beginning. Because at that point, I suppose most of the people remember here, given the venue, Chromium had not been split from WebKit yet, so Chromium was another WebKit port. So they, of course, choose to use WebKit for that. And it was 2013 that they announced in April that Blink/Chromium would be stripped out from the WebKit repository and made into an independent project, and has been like that ever since. So it was also around that time that they decided to switch the Android WebView component to use Chromium. Some unofficial community Android builds kept using the WebKit-based WebView for a while, but of course eventually they had to remove it because it was unmaintained. And the moment where they did that was 2014 onwards, when Google made it so the Chromium-based web view would be separate from the rest of the system and could be updated independently, which allowed them to avoid building Chromium as part of the build process of their Android system images, and being able to install it separately. And as for why do we want to have WebKit running on Android again, it's one of the things, or one of the main things, is that Android as a base system is interesting for a number of reasons. One, which is very obvious, which is not even there, but doesn't matter, is that the installed user base is huge, which means if anybody needs to find a device to do some development or tinkering with it, or use it if at some point there's some application that is mass-oriented, there's already a huge installed user base. Now there's a different discussion about why somebody would want to use WebKit for that. We can get into that as well, instead of Chromium. But the truth is that there is a huge user base, and the pool, the influence of Android as a system is big enough that hardware manufacturers are providing support for their systems, for their chips, for their GPUs, etc., for Android sometimes, and not so good support, or if at all, for regular GNU plus Linux or non-Android Linux, let's say. So that means we get base system that is more tested, often has more features, especially when talking about GPU drivers, even though the situation has improved a lot in the last years, and which can be considered to be stable also from the point of view that Android has been pretty good at keeping backwards compatibility. So that means, in theory, it's a desirable target because we have all these advantages that would save us, for example, from dealing with different kinds of incompatibilities in drivers, in different Linux distributions which may be arranged in different ways, because an Android system, a system based on Android, is going to have a base that is the same for all of them, because at the end of the day, Google enforces that to certify devices that then manufacturers want to sell. So in that regard, it's a solid base system that is attractive to target. And another reason why we may want to run a web engine that is not Chromium on Android is that in some systems, we know that it's being used without the upper layers of Android. So you can use Android, the lower layers, like the kernel, the userland, that is native code, and libraries, drivers, etc., without including the graphic system, for example, and anything that needs the Java virtual machine runtime. And that is something that we have seen. And in that case, Chromium doesn't run because there is not a build option for Chromium that you can tell it, okay, I want to run on Android, but I don't want to use the Android user interface. That's basically not possible at the moment. But that is something that is relatively easy to do with WPE, because if we go back a second, if it wants to go back, it was here. We have these three parts that we have the platform integration as a separate component. So if you don't want to run the widget part, the WebView widget that WPE-Android provides, you can ignore the last part. You can just not build it, and it works. So that's an advantage that we have, for example, over Chromium, and it's something that WebKit being more flexible in this regard allows us to do. And then there's other reasons why this project was started. I was like, we already had WPE WebKit, and it seemed like a nice idea, just the thought of why not bringing back WebKit to Android, where it was at some point. If we have WPE as a base, which is a port of WebKit that doesn't mandate a particular user interface or a particular user interface toolkit, so we can do the adaptation based on WPE WebKit without having to write a complete WebKit port, which would have been much more work. So from that point of view, it seemed like a good opportunity also to prove that WPE can be adapted to many different kinds of systems and not only regular distribution-like Linux systems. And of course, now we are getting into the territory of social politics, I guess. As one may also decide that doesn't want to rely on Chromium or on Google, who develop Chromium for the most of part, and then go with a different option. For whatever reason, there can be many. One of them could be as easy as the reason I was mentioning earlier, that I don't want to use the Android user interface, because I want to have something that uses the Android drivers, but not the rest of the UI. One may want to not use Chromium to make sure, for example, that you ship in your application the web engine that is a fixed version with a feature set you know that is going to be always the same. So you are targeting that particular web engine with that particular set of features, and you don't have to rely or be at the mercy of an update in Chromium breaking your application, for example. Because you are, with WPE-Android, the way it works nowadays is that you ship the libraries that make part, that form it as part of your Android application package. So it's bundled with your application. So from that point of view, you know exactly what you're targeting. So it can be cost savings, for example, when developing an application that has web content and that you know you don't need to target different versions of the Android web view, for example, which was more of an issue in the past when Chromium was evolving quickly, for example, or during the transition from WebKit to Chromium-based web view. Applications that use the system web view widget often would have strange bugs or would plainly not work depending on which version of Android you had, because the package with the WebView implementation would be updated as part of the whole system. So it was quite fragmented. The platform was quite fragmented from the point of view of the versions of the WebView shipping at the same time in many devices. And also another motivation that we think it's interesting is making a small dent, a small contribution, even if it doesn't end up used for applications that have billions of installations, to have like the proof that one can target Android with a different web engine, and it can work, and that contributes to have a more diverse web engine ecosystem, which is good for the web overall. I think everybody can agree to that. And yeah, like I was saying, I was checking, and we actually started in 2017 with this. Initially, I'm going to do a next slide, and then I'll go back. One can see quite clearly how the evolution has been. This is accumulated a stack plot of commits in the Git repository. This is only for the main WP-Android repository, but it's quite a good example of how it went. And the decreasing of each stack line is commits that were at some point, and then they were being replaced, their lines, by lines in other commits. But anyway, the total amount is the total amount of lines. So yeah, it started in 2017. It was kind of a small demo project, that's proof of concept. And yeah, it was 2017, a small demo, got a bit, stayed there. Nobody was paying it much attention until 2001, 2022. Then we picked it back, rewrote some parts of it, and started to use Android's GL Surface view. But then the interesting things started to happen in 2023, which is not that long ago. And that's about the time when the last talk was done about WP-Android. And at that moment, we got an NLNet grant to work on WP-Android. So then we started working on it again. And the results of getting back to it started in 2024 by the beginning. For easiness of maintenance, we dropped 32-bit support. But for example, things which were running a bit awkwardly were integrated better, like the glib main loop, because we use glib in the WPE port, got integrated with the Android main loop, which is good, for example, for battery savings and so on. We got multi-process working in the sense that security regions are isolated, that the process swap on navigation. We managed to get multimedia decoding on hardware using GStreamer's Android components, which offload the media decoding to stage fright, which itself may have hardware acceleration. And 2024 August, a lot of things again, many new features. Like it can be, it's quite clearly like 2002 there's a bump, 2024 bigger bump, and then 2025 is where we are now, up top. We're at the point now, at some point there was, one of the things that was done during 2024 was reducing the amount of patches that were applied on top of WebKit when building it for Android in particular. There were at some point 170 something patches, and that went down in chunks of some tens of patches, some tens of patches. By 2025, beginning of the year, we had about a dozen only, and at this point we don't have any Android-specific patch which is applied on top of the WebKit tree. That means that with the needed dependencies, if you build it, for example, using our Cerbero fork that has the needed recipes, the WebKit package that builds for Android is exactly the same that is distributed as a Torvald release for any other system, which is quite nice and makes development much nicer. Which means one can also point the build recipes to the tip of the tree, and at this point one can build Android from the tip of the tree without any change whatsoever. Something that may happen sometimes is because we don't have CI for the Android port connected to the general WebKit CI, is that there's a commit in WebKit that breaks the build for Android that we fix quick, but it can happen sometimes that following main will not build, but in theory should. And well, that's something that started in 2024. We are also maintaining a Maven repository. So if some Android developer wants to try to embed the web view that uses WPE WebKit in their application, they can add one line in their package configuration, and binaries get downloaded automatically by Android Studio, for example, or any other development environment, and you can just use it. You don't need to spend 4 or 5 hours, 2 days figuring out how to build the whole thing and have it running. We fixed things to have it working on Android 15, which is the most recent version. It's currently the stable release is using the previous to last 2.48 release, which is the latest stable series. So it's basically following quite close upstream WebKit development at this point, which is quite nice. And yeah, we're even using Skia. It's possible to use GPU acceleration for rendering on Android. It works. It's not necessarily much faster than using Skia with software rendering, but it works, which is nice. And now we're at the point where I say, well, and what do we have coming out of the oven soon? Well, there's a number of paper cuts that need quality of life improvements. Most of them are that there's either some platform API missing, in the sense that, for example, at this point, WPE-Android is not respecting the power status reported by the system. So if you're on battery, well, it's not going to be trying to use less battery. But that's something that can be done in the future. It's not terribly complicated. It just needs a bit of time to do it. There's APIs missing where we have been trying to copy or mimic the public API of the Android system web view. It just that instead of web view is called WPE view, and then the methods tend to be the same if it's being used from Java or any other language that runs on the Java virtual machine. But many of the APIs that the system web view has are still not implemented. That's not difficult to do either. It's just something that takes time, and it's how is it called? It's menial work, right? But it can be done, of course. So that's more things that we need to do. continue the regular maintenance, etc. We have ideas to reduce the size of the binaries that are pretty big because we're bundling the streamer, for example. Even when not all of them are used, we're shipping also many of the GStreamer elements that are also codecs provided by the Android system GStreamer elements. So we have, for example, duplicated codecs that we wouldn't need to ship. But that's also things that take time, but they're not like strictly needed to have things working and continue improving things. What we would like to work at this moment on, or what we have the idea, is start picking commits from the main branch that we know work for Android, and make the main branch of the WPE-Android project follow those. So have a branch for the stable releases, and then that main follows main. At this moment, the main from WPE-Android is following point releases. But it would be nicer for testing to follow the WebKit main as well. And there's one item there that maybe doesn't sound very exotic, but we have been working on a new API for WP, and to give an idea, we call it WP platform. The old API, I'm going to call it the classic API. With the classic API, we have, for example, the mini browser that we have in the WebKit tree is about 600 lines and plus 1,000 lines of the WP backend that makes WP present content on Wayland. But if we get a slightly more featureful browser, like the launcher included with the Cog library, that's 3,500 lines for the part that implement the Wayland support, plus almost 5,000 lines from the backend, plus the launcher itself. So it's pretty verbose. And anybody who wants to do a different adaptation of WP to a different platform, including Android, has to go through a lot of that code, and it's not always the same code, of course, but there are things which are common, and it seems a bit wasteful from that point of view. And to give a taste of the new API, I like to put this example, because this is a complete browser with the new API. This will not work on Android, of course, because not directly, because it's C using the glib GeoJet API that we have for WP, but it works on desktop Linux, and it's 32 lines. That's how it should be, ideally, to write something that opens a window with a web page on it, not 600 lines, right? And this new API that we have been working on for WP platform comes from the fact that the classic API has a number of problems. One is that it's very verbose, like I was trying to exemplify with the line counts. It's plain C. It is not well documented or not documented at all in some cases, which means also there is no hints often in the documentation about life cycle of objects and who is responsible to deallocate or allocate what. It's confusing sometimes what it does. The names of parts of the API, especially when implementing a WP backend to adapt WP to a certain platform, there are terms that make sense, but they're not the usual terms that one would expect. So one doesn't, for example, implement view implementation, that is what shows the view in something. One implements a render target interface, which doesn't sound like anything. It's like, has a lot of these terms which are confusing. So it's not a good API from that point of view. It has served us for many years, but we would like to change it. And what we're doing with the new API is we're basing it on GeoJet, like the same as the rest of the WPE WebKit public embedding API, which means the roles of each object are clearer, the life cycle and who allocates, who deallocates, what is reference counted, what is not, etc. That is part of the type system. It's still C, but at least it's C with objects. And there are good practices and annotations that we can add to include that information in the documentation and also it can be used for linting, etc. So it is better from that point of view. It has already better documentation, even when it's not completely documented. It has better documentation than the old one, and the names make more sense. In general, like the idea is that the design of the API will encourage the people who are either writing a browser or writing a platform implementation to try to nudge them in the right direction to avoid having mistakes. And while working on it, we decided that we had a number of years of experience working with the old API, and we had reached some limits in what we could do with it, some odd corners that we couldn't fix without changing the API. So we took the advantage of designing a new one to try to fix those. So a nice thing of the new API also is that it's designed in a way that it tries to facilitate that, for example, when moving graphics buffers from one process to another, WebKit is multi-process, by the way, even on Android. By the way, the system web view, I think it wasn't multi-process until a couple of years ago. Anyway, but yeah, and or when doing composition or different paths inside the graphics pipeline of WebKit, there is more information that allow to avoid copying graphics buffers, for example, or transforming them, or changing their pixel format and so on, which gives us improved performance, but also other niceties like less battery usage, for example. Also, we wanted to make it use a new mechanism that we have inside WebKit that's called display link, which basically talks at a lower level than, so often at a lower level than the system user interface toolkit, to ask the hardware directly what is the moment at which you are presenting and going to give time to prepare a new frame. It's like related to vertical synchronization, if you want to think about it like that. So we can more efficiently schedule when to paint, when to try to have the painting ready to be displayed, and so on, which is something we couldn't do with the old implementation, with the classic API. So that's also something that that is coming for free with the switch to WPE platform. And from the point of view of Android, there's a couple of issues that we have. That is, this is something that is being worked on at the moment. Until these weeks, we have not yet added support for the Android hardware buffers to move graphics among processes. That is now being worked on. And the API doesn't cover, well, for those who don't know, Android has this thing that you cannot fork and exec processes like in a regular Linux system if you are using full Android with the whole Java virtual machine, etc. But there are system services that you can request to have a background process, etc. And you have to go to those through Java. So if you are writing the platform adaptation in C++, we have to go through the Java native interface, call up to Java objects, get the results back, and then finally we get a process launched. And that means we have extension points with the old API to launch processes, which are only used by the WPE-Android port, and I think the PlayStation port. WebKit has a PlayStation port. But we don't have those in WPE platform yet. So yeah, we still have things, a few things missing. And while the WPE backend API is still in flux and still moving, still evolving a little bit, it has reached in the last months the point where it's quite feature complete. And what we have been using in the last months has not changed much. So we are quite close to, I believe, quite close to feel confident to consider it 1.0 API, 1.0 from the point of view of now it's stable, and to start guaranteeing backwards compatibility. Until we reach that point, we may still change things in incompatible ways, but it has not changed much in the last 4 or 5 months. So we're getting there also with that. And we may do things like consider it stable without adding the process launching customization possibility, which as an addition wouldn't break the API or the ABI later. But we'll see. But we're close to get WPE-Android working with the new API, and well, for improved performance and battery usage. And that's where we are at the moment. So I would be super happy now if anybody has questions or doubts or comments.
Yeah, so in some, like for some application developers that use like basically websites internally, but develop applications as like Android and iOS apps, and even Electron apps or something like that in the desktop. They sometimes want to use one single browser engine to avoid differences. So and in that sense, I was wondering, how close would Android WPE be to iOS in various extents?
Okay, that is a great question. How close would be WPE Android on? How close would be WPE Android to Safari, for example, on iOS, if one wants to target it? And the answer is quite close, except for some APIs that are device-specific that we may not have implemented yet. So, for example, I think we don't have yet orientation events, for example. There's WebXR is in progress. It doesn't have, like, we have some WebXR support, but it needs rewriting. It's not very multi-process friendly in the way WebKit is designed, so we have to move to a model which is closer to Apple's. But it's the differences that there are is not because WebKit is not capable, it's because we either have not exposed those yet, or we are missing some kind of platform integration that would enable them. I don't have a list with me, but ideally, if we had all those implemented, they would be close enough that I would say 90%, 95% similarity, most likely.
Hi. Here, I'm curious, have you compared in terms of things like binary size, performance, etc., to GeckoView or whatnot? Because my understanding is that's a relatively similar thing, where like GeckoView is the package that provides the WebView-like API. It's more oriented to Java, as I understand, versus what you're doing. But yeah, I was just curious if you had run any comparisons in that regard.
Yeah, so the question is if we have done performance comparisons with GeckoView, for example, or Chromium, I guess. No, we have not. We're at the point where we are focusing on having features implemented still, moving to the new WP platform API and so on. We know that there has been an increase in performance since the switch to Skia, which arrived a bit later to WebKit on Android because it had some platform integration to solve. And like the mini browser now built in release mode, like it's fluid enough to regular browsing on a mid-range Android phone, but we have not done like running motion mark or any other benchmarks until now.
Cool. Thanks.
Thank you, Adrian. Thank you very much. Very nice talk. Unfortunately, we don't want to hijack more break time. So it's break time, folks, and we will have our next talk in